In this problem, we are given the acceleration and we're asked to find the velocity and position from the acceleration. We know that the velocity is the integral of the acceleration. So we need to do the integral of the negative cosine t sine t. Now, the integral of negative cosine t is going to be a negative of sine t, and the integral of sine t is going to be a negative of the cosine of t. Now, that will have some constant of integration, which has to be also a two-dimensional vector, because we have a two-dimensional vector that we're integrating. I'll use C1 and C2 for these two numbers. Then we need to find the C1 and the C2. To do that, we use the given information that v of 0 is equal to the vector 1, 1. So that vector 1, 1 needs to be what we get when we plug a 0 in place of these t's. Negative sine of 0 is still 0. The negative cosine of 0 would be negative 1. And we get our constant of integration vector by subtracting 1 minus 0 and 1 minus negative 1. Using that constant of integration and putting it back in here, we've got v equals a negative sine of t plus 1, which we can write as 1 minus sine t, and the negative cosine of t plus 2, which we can write as 2 minus cosine t. So there's our velocity vector, v of t. We need to do the same thing with the velocity vector that we just did with the acceleration vector. The position function is the integral of the velocity. So to find the position, we need to do the integral of what we just found. So the integral of 1 minus sine t, the integral of the 1 is going to be t, and the integral of the negative of sine t is going to be a plus cosine t. The integral of 2 is going to be 2t, and the integral of negative cosine t is going to be negative sine t. And likewise, we have a constant of integration consisting of two numbers, which I'll go ahead and call C1 and C2. We find those by using the other given information. We know that the vector 0, 0 is going to be what we get when we plug a 0 in place of the t here, which would be 0 plus cosine of 0. That would be a 1. And 2 times 0 minus the sine of 0. That would be a 0. So, to find the C1 and C2, we simply subtract. So when we subtract this vector from the other side, we get 0 minus 1. And 0 minus 0. So we need to put that back in here. So r is going to be t plus cosine t plus negative 1. So that would be t plus cosine t minus 1. And 2t minus sine t plus 0 would still be just 2t minus sine t. So in this one, we are given the position. To find the velocity in number 87, we need to do the derivative of the position. So we do the derivative of cosine t, which would be a negative sine t. We do the derivative of 2 sine t, which would be 2 cosine t. And we do the derivative of 0, which is still 0. So there is our position function. To find the speed, we need to do the magnitude of the velocity. Well, we can do this easily enough on our calculator, which I've already done. The derivative of r is this. To do the magnitude of that, we come out with the square root. This simplifies to 3 cosine squared t plus 1. And so at t equals pi over 4, this would obviously be the square root of 3 cosine squared pi over 4 plus 1. We can do that on our calculator. That simplifies to a square root of 10 over 2. Then on the last one, to find the acceleration, we need to do the derivative of the velocity. And so if we take what we found in number 87 and do its derivative, we get the vector derivative of negative sine t would be negative cosine t. The derivative of 2 cosine t would be a negative 2 sine t. And derivative of the 0 would be the 0. Now we want to find the acceleration at pi over 4, which means we need to plug a pi over 4 in place of the t. So this ends up a negative square root of 2 over 2. This is just a negative square root of 2 and a 0.